Welcome back, everyone. In Module 5, we're going to look at configuring and managing virtual networks. This is an incredibly important topic because it allows us to do a couple of major things. It allows for our virtual machines to communicate on the network, and it also allows our ESXi hosts themselves to communicate on the network. And there are a number of different reasons why each of these things might need to be done. So in this module, we're actually going to have a look at how we accomplish virtual machine networking, as well as how we accomplish ESXi networking for all of the different reasons that ESXi needs to communicate on the network. Things like management, IP-based storage, vMotion, replication, vSAN, all of these different reasons why ESXi itself needs to communicate on the network. So what this module is about is how we architect that, getting an understanding of virtual networking, as well as how we accomplish this in the vSphere client. We're dividing this module up into two different topics. And the first one is the introduction to the vSphere standard switch. Now, by default, vSphere comes with two different types of virtual switches, the standard switch and the distributed switch. The distributed switch is limited to those with Enterprise Plus licensing. And if you're interested in the distributed switch and you want to get down and dirty on that, our Optimize and Scale course spends a significant amount of time on the distributed switch. But as this is an introductory course, we're going to focus our work here on the standard switch. In lesson number 2, we're going to have a look at some of the policies that we can set around networking and teaming and failover for that standard switch. When it comes to use cases for this, if you asked a couple of network engineers to solve a problem, they'd probably come up with 5 different solutions for you. So it really relies on us as vSphere engineers, as vSphere administrators, as well as us as network administrators to determine what the architecture for our networking is going to be and what features around networking we'd like to use. Now, in most environments, we'll be using things like VLANs to make sure that multiple networks can communicate over the same physical infrastructure, over the same physical NICs on your ESXi hosts, over the same physical switches, and things like that. We also need to consider the availability of bandwidth in the environment, making sure that the services that we are running networking for, things like IP-based storage versus virtual machine communication, that all of those different services have the bandwidth that they need. Okay? And we want to make sure that those different services don't interfere with one another. So we'll look at how that's done as well. We also want to make sure that we avoid single points of failure in the environment. So NIC teaming, standby, active and failover, active and standby networking and physical ports are also important in this environment. Okay? So it's our job as the administrator to architect this as well as to implement this networking. So why don't we start right off by looking at standard switches and understand a little bit about virtual networking itself. We'll look at the different types of switch ports on our standard switches. And we're going to look at how we view and configure those standard switches themselves. And then we'll look at a little bit of the difference, just a little bit, of the differences between the standard switch and the distributed switch. So when it comes to implementing your environment, you can decide whether or not the distributed switch is something that you actually need, and then you can ensure that you've got the right licensing from VMware so that you can use distributed switches. So what do virtual switches do? Well, they provide connectivity between your virtual machines and the physical network, virtual machines and other virtual machines on the same ESXi host or on another ESXi host, and they provide connectivity between your ESXi hosts through what we call VM kernel services. This is the VM kernel, so ESXi, connectivity to other ESXi hosts for things like vMotion, iSCSI, NFS, management, and so on, right? So virtual switches are critical components of your vSphere infrastructure. Your physical switches typically just have one type of port, right? You're connecting an Ethernet adapter from a device into your physical switch, and it allows all of the devices on that switch to communicate with one another. Well, there's a little bit of a difference in a virtual switch, because in a virtual switch, there are actually two different types of ports. There's one type of port for connecting your virtual machines. We call those virtual machine port groups. Okay? And that would be very similar to a standard Ethernet switch. Okay? But we also have what are called VM kernel ports. And in a VM kernel port, what we're using those for is to connect ESXi hosts to one another, as well as to IP-based storage. So VM kernel ports are used for things like iSCSI and NFS traffic, vMotion traffic, fault tolerance, vSAN, replication, and most importantly, of course, ESXi management traffic. Okay? So those are the two major types of connections that you'll find on a virtual switch. Now you also, of course, will have uplink ports on a virtual switch. Those uplink ports are simply pass-throughs to the physical NICs on your ESXi hosts. Now, if you look at these virtual machine port groups and imagine connecting virtual machines to them, imagine a virtual machine sitting up here, right, and a virtual NIC connected to it. That's connected to the virtual machine port group right here. So the virtual NIC will contain all of the information that you would need to communicate on the network, right? That virtual NIC in your virtual machine will have a MAC address, will have an IP address associated with it, and so on. But when it comes to your virtual machine, when it comes to your VM kernel ports, all of that information is configured at the ESXi level. So on the VM kernel ports itself, we are going to have the MAC address of that VM kernel port. We'll have the IP address of that VM kernel port. We'll have the VLAN associated with it, and so on. Now, of course, there are lots of different ways to accomplish the same sorts of things. And in the example that we have here, we want to make sure we're doing things like avoiding single points of failure on our network. So what we're doing here is we're attempting to make sure that each of our services that we're trying to run in our vSphere environment have multiple physical ports. Okay, let's start with our virtual machine port groups here. Now you'll notice that we have two different virtual machine port groups. One set of ports for production and one set of ports for test and development. And you might imagine that in your environment, these port groups might share the same physical ports, or they might have different physical ports. And if they're going to share the same physical ports, you're going to need to establish VLANs here. So here I will associate my virtual machine port group for production with this NIC, and maybe I'll do my test and development with this NIC. But don't forget, we're trying to avoid single points of failure. So why don't we take production and we'll make this NIC over here, we'll make it the standby port. And for test and development, we'll make this NIC here its standby port as well. So now you can see that we're avoiding single points of failure, but in order to do this, we're going to need to have VLANs established so that if you had to, both of these production and test and development virtual machine port groups could participate on the same physical port. Now these other ports that we have here are VM kernel ports. So in a VM kernel port, we're going to establish on the ESXi host its IP address, its subnet mask, and so on. So for management, maybe I'll use this port. Whoops, that one right there. And for vMotion, maybe I'll use this port over here. Let's not forget iSCSI for our storage, so I'll do that over here. We want to make sure that we separate storage from our management traffic for a couple of different reasons that we'll explain a little bit later. And of course, you want to avoid single points of failure as well. So if you had to, you could do a standby adapter for each of these devices as well. Now, this is an example of all of these services using a single virtual switch. But we could also accomplish this with separate virtual switches. Now, in this top example, I have an ESXi host with 4 physical NICs down here. So on my virtual switch, there are uplinks that are pointing or passing the traffic through to those 4 separate physical NICs. Now, down here on the bottom, this is an example of how I might accomplish the exact same thing, but with a different architecture. So here I have got a virtual switch for management. And of course, I need to avoid single points of failure. So this one will go with this port and as active, and maybe I'll use this one as standby. And I'll do the same thing with vMotion, active and standby. I'll do the same thing with my production systems, right? As well as test and development virtual machine port groups, and my iSCSI or my storage traffic, IP-based storage traffic, active and standby. Now, in this example on the bottom, you can see that I have not 1 or 2 physical ports here, or 4 like I had up here. I actually have 10 physical NICs. You cannot have a physical NIC being associated with more than 1 virtual switch at a time. Otherwise, it's really just 1 virtual switch if you think about it. Okay? So if you have 10 physical NICs in your environment, then by all means, you can do something like this on the bottom, right? 10 physical NICs on each host. Not very many of us have that in our environments, so VLANs are a way to get around that. And in that case, we can certainly use a single virtual switch. It's really up to you. Speaking of VLANs, we wanted to do a little bit of a deeper dive on VLANs for you here, because it's important to understand how they're configured. Now, whether or not I use a virtual machine port group or a VM kernel port, I can establish VLANs, okay? And the VLANs are enumerated, or they're listed in the vSphere client on the virtual switch itself or on the VM kernel port. Sorry, on the virtual machine port group or on the VM kernel port, okay? In this example, I have 2 VMs and I've got 2 separate VM virtual machine port groups. I've got this VM plugged into a virtual machine port group where I've set up VLAN 105. I've got this VM on a different virtual machine port group where that's set up as VLAN 106. And they are both directing traffic to this same physical NIC. All well and good. Now, when it comes to the physical port that we plug this into in the virtual switch, we have to note that as we do this, the physical switch has to be able to understand that VLAN tagged traffic is going to come through this, and there might be multiple VLANs, and so we'll establish a trunk port on our physical switch to allow traffic that's coming into the physical switch, and then out the physical switch up into the ESXi host so that the VLANs get passed through. So now that we have the VLAN tags being passed through into our ESXi host and into the physical NIC on the ESXi host, any traffic tagged with VLAN 105 will come into this virtual machine port group. Any traffic coming in that's tagged as VLAN 106 will come into this virtual machine port group where the tags will be stripped. So the tags then will be stripped when they reach the virtual machine port group, and the traffic will then be passed untagged into the virtual machines themselves, okay? Any traffic coming from the virtual machines, once they hit the virtual switch and the virtual machine port group on the virtual switch, that tag will then be added and then pass through the physical NIC and then out to the physical port on the ESXi host itself. Okay? So that allows us to separate traffic, on multiple networks when we're using the same physical ports, which is a really, really useful system. Now, the nice thing about using VLANs is that the effect on performance is very minimal. We have a very simple tag in an Ethernet frame that ESXi will read and pass to the right place. When you are creating your virtual machine port groups or you're creating your VM kernel ports, you'll note that the VLAN ID can be one of three different things. It can be either VLAN ID 0, which simply means we're not using VLAN tagging at all. It can be VLAN 4095, which means we want to take all the VLAN traffic and pass it through the virtual machine port groups with the VLANs intact and allow the virtual machines themselves to deal with the VLAN tags. We call that guest tagging. Or we can actually specify the VLAN ID right here and type in the number. Okay. So now there are a couple of different types of virtual switches here. We just talked to you about the standard switch, but we also have the distributed switch as well. The distributed switch is simply a more advanced, more feature-full virtual switch that will run on an ESXi host. Now, the nice thing about a distributed switch is that the distributed switch is configured at the vCenter level. So any configuration that you do to the distributed switch only needs to be done in one place. And that configuration that you make at vCenter will then be able to be passed down to the ESXi hosts. Where on a standard switch, those standard switches need to be configured uniquely for each of your ESXi hosts. And that opens up room for error, user misconfigurations, and those sorts of things. So the simple management of a distributed switch, especially in a much larger environment, is so much easier because it's just one single interface that you have to work with, and then that configuration gets passed down to the ESXi hosts. We can actually support up to 2,000 hosts on a single distributed switch, and it maintains that consistent configuration across all of the hosts in the environment. Okay? There are two ways to get a distributed switch from VMware. Either use vSAN licensing, right? So if you have vSAN in the environment, you get the distributed switch. Or if you don't have vSAN, you can get the Enterprise Plus license for vSphere. So when we come back, we're going to look at how we kind of push the buttons and twist the knobs in establishing virtual networking on your ESXi hosts for standard switches.